Right with you. Getting my papers together. Okay, a couple of terms just to let you know that they're out there. Presbyopia. I said something about this real briefly. Presbyopia. Presby apparently means old. So presbyopia is a situation in which the lens becomes rigid. Lens becomes rigid with age. Rigid with age. So that no matter how hard the muscles try, it can't get the lens to focus. And this is apparently corrected with converging lenses. Converging lenses used for correction. Okay. Converging lenses, like the case of the nearsightedness. That's one term, presbyopia. The other one, which you've probably heard more often, is astigmatism. Astigmatism. And that's where there's an irregularity in the lens or the cornea, but it is asymmetric. Okay, that means that not only the problem is not the same everywhere, that there's some asymmetry involved. Maybe the lens bulges a little bit on the side for whatever reason, or maybe it's become rigid on one side first before the other. Okay, astigmatism, and what that does is it would take, like, if you were to look at a star in the night sky, for example, a bright star, or say Venus, which is super bright, especially these days. Go out west after sunset and look up the real bright thing that's so bright you think it's a plane, but it doesn't move. That's Venus. If you look at Venus and it looks like it's a little line instead of a point, you might have astigmatism. And that, again, that's created by asymmetries in the lens or cornea. Okay, so that's an asymmetry. How do I have it worded here? An asymmetry in the lens or cornea. And that's corrected for by lenses which have a certain prescription in one dimension, but another prescription along another dimension. Okay, I'm not going to roll that out here because it's not important as far as immediate need for doing homework and stuff. But that's how astigmatism is corrected, is for by lenses which have different prescriptions along different axes. Okay. Which is really strange to think about, but you can do it. You can do it in your X prescription one way and your Y prescription another. And that asymmetry can correct the asymmetry in your eye if you've got astigmatism. So there's that. One thing I wanted to find finally is that people who, doctors, eye doctors, use something called the power. This is not a watt, like we talked about earlier in class. It's not a watt. It's a power of a lens. And the power is defined as 1 over the focal length of the lens with F measured in meters. So if F is in meters, P is in a unit called diopters. Funny word, diopters, but there it is. P is in a unit called diopters. So for example, if your focal length of your lens, of your eye, or corrective lenses is, say they're diverging lenses, say the focal length is minus 20 centimeters, okay, then the power that you need for the corrective lenses is 1 over minus 0.20 meters, right? that would be -5. Is that showing up? Yes, -5 diopters. And that barely fits in there nicely. Yeah. Okay, so power is measured in this thing called diopters. And if you had converging lenses, power would be a positive number because the focal length for a converging lens is positive. All right. Okay, I think I've filled the board up enough for this one. It's a little short, 5 minutes, but that's okay. We will get to the example in video number 4, which is up next.